Welcome to this microwave tutorial on how to use NVIDIA digits. My name is John Murphy, and in this tutorial we will build an image classifier comprised of an artificial neural network. We'll be using the latest version of digits, version 2.1. For computing the network, we'll use 4 Tesla K80 GPUs. Assuming you already have digits installed, we'll walk through how we start the digit server on our cluster. Depending on whether you are running digits on a workstation or in a cluster, starting digits will involve different commands. Since the details of starting the server will differ depending on your system, I will just quickly demonstrate how digits is started on our test cluster. We're running Slurm, the Slurm batch scheduler, and your command invocation for submitting batch jobs may not be the same as ours. So we use a bash shell wrapper script which requests resources from Slurm, and this particular script that I am now going to invoke will request 4 Tesla K80 GPUs. So I'm running this now. The scheduler is allocating a compute node, and this typically takes a few minutes to start up. It's reacting very quickly now. So in just a minute or so, we should get a message from the digits server indicating that it's up and online. Okay, so here's the ASCII art banner indicating that the server is running on the machine on port 5000. So at this point, you can go to your web browser. Here I'm using Firefox, and actually we want to check which node we're on. We're probably on node 6, so I'm going to enter node 6 here, port 5000. So it should take just a minute to respond, and then we'll be on the digits landing page. Okay, so here we are on the landing page, and indicated here in the upper right hand corner is the information that we have 4 out of 4 GPUs available. There are 2 GPUs per Tesla K80 card, so that means that we have 2 cards in this particular node. So from here we want to create an image set. So under new dataset, click on this images button and then select classification from the drop down menu. So this takes us to the this dataset creation page. There are different tabbed areas here. We're going to use images from a folder, a directory of folders that I created. Here we're going to classify 2 objects, in particular 2 types of SUVs. One is the 2015 Jeep Cherokee, and the other is the 2015 Land Rover. So I have 2 subdirectories that are in that are nested within a parent directory. So we will start by specifying the path to the parent directory here in this field. So I'm at home, John, NVIDIA, digits, we're in images SUV expanded set, so that's our parent directory. There are two subdirectories nested within this parent directory. So okay, we've selected that directory. Now when we have all of our images in all the validation and training images in the same directory, there's no need to specify separate folders. I mean, you could specify a separate folder, but here I have them all in the same subdirectories, so digits will sort of automatically select images for validation. We don't have to select any images for testing. Okay, so there is the other option of using text files. If you use a text file, you are required to have at least a training file and a validation file, which basically consists of a list of URLs that point to images on the web. So we're just going to use these images that I've already collected, and actually I expanded the image set, so it was amplified by sampling or taking subsamples of the base set. I expanded each category to approximately 30,000 images. So this was done in order to prevent the neural network from becoming overfit to the data. So whenever using a deep network, you will want to ensure that the image set is large enough in order to prevent overfitting. Otherwise, the network may not perform well at identifying test objects, which might deviate in appearance from the sorts of objects in the training and validation sets. Okay, so there are several more techniques to prevent overfitting, which involve concepts that are not within the scope of this tutorial. Okay, so now to create to finish this dataset creation, I have to change this default here for the image encoding from PNG to JPEG. My images are all in JPEG format. So one other note here about the image size. The default is 256 by 256. That's because two of the neural networks that are standard in digits expect the input images to be of these pixel dimensions. If your images are not exactly 256 by 256, if they are larger than that, or if they do not have a 1-to-1 aspect ratio, digits does have this resize transformation feature, which is very convenient. It will automatically scale your images so that they are exactly 256 by 256, or else they wouldn't fit into the neural network input. Okay, so now finally, I'm just going to name the image set. So I'll come up with a subject appropriate name, SUV image set. This is an expanded set. I expanded upon the original data set by doing window subsampling. So I'll call this expanded, and then this is a tutorial, so I'll just append it with tutorial. Okay, now to start creating it, we just click create. And this set is comprised of about 60,000 images. So it's going to take about 10 minutes for it to run through and create the database the database files and everything that sit in a hidden directory within my home directory. So as you can see, it's already started. You can monitor the progress here. There's the progress bar. If we scroll down a bit, we see this bar chart, which indicates how many images are in each category in our training set. So we have approximately 28,000 or 29,000 for the training, and then down in validation, that's just 25% of the original total, so we have about 10,000 here. Okay, so I'm just going to I'm going to let this run for a while. You see here it's already at 7% and it's estimating 12 minutes remaining. So I'm just going to pause this and then we'll resume when this is finished making the data set. Okay, so we're back. There's only about a minute left for the database build. I just wanted to show you my directory organization. So you can see the path here is pointing to some parent directory, and I have the two subdirectories for my two different object types. This text file you see here is really just something that was left over from when I was running with text file inputs, and this was actually for another classification I was doing on aircraft. Alright, so here again we have these bash shell wrapper scripts, and we can take a quick look at one just to give you a sense of how we request resources on our Slurm batch scheduler. So there's the salloc command. So here we're requesting 2 CPUs and a total of 4 GPUs. This of course has its own particular syntax, and if you're not using Slurm, this of course won't be very helpful to you. But let's take a look at the job queue. It's just indicating that on node 6 you can run digits on a desktop workstation, or you can run it on a cluster. If you're running it on a desktop, the invocation for starting the server is somewhat simpler. You really just have to invoke this command here at the command line in some terminal, digits -dev server, and that will start the digits server for you if you're just running it on a workstation. However, if you're running it on a cluster, you have to work with the job scheduler, and depending on whether you're running SGE, Torque, PBS, or something else, the invocation will be a little bit different for your setup. Okay, so it looks like the database build is done. So let's go back to the digits landing page. Okay, now from here we want to click on the images button under the model section. So we'll get a drop down menu again, and again select classification. So this will take us to a GUI where we can specify parameters for our neural network. So here on the left we see the data set that we just created, so of course we're going to select that. Here we have options for transforming the data. Generally, I think you want to subtract the mean file. That helps with the network performance. Down here we have some tabs, and under standard networks we have LINET, AlexNet, which was the disruptive network that was published in 2012, and there's GoogleNet, and we'll click on GoogleNet. And next, once you make your selection, you can click on the Customize button to get some information about how the network is structured. In this text field here, this is called prototext, and it's basically a high-level description, a descriptive language that basically describes the elements of the neural network. Then there's the option of visualizing the network, which calls up a nice illustration with all the layers and the abstract representations in the network. And it's taking a bit of time to come up. So you can check that out when you take digits for a test drive. There's also the option here of using the previous networks. Since I have run image sets in the past, and I've run classifiers, I've built classifiers before this, so if you select previous networks, the classifiers that you've built before will come up as options that you can use again. Okay, so let's look at the solver options. For large networks, or what are called deep networks, and large image sets, generally you want to increase the number of epochs of training. So here I'm going to increase this from 30 to 60. My interface has become a little bit unresponsive. Sorry, I just have to wait a second for it to come back. Okay, let's take a pause here. Okay, we're back. So here is the previous network tab, and this just has some radio button selections of previous networks that I had trained. So under solver options, as I was saying before, we want to change this to 60. And then for the learning rate, which is by default 0.01, we want to decrease that to 1/2 of that value, 0.005. Keep the solver type stochastic gradient descent. This advanced button just pulls up some parameters that we can use for essentially sculpting the learning curve, or the learning rate curve. We don't really need to use these features to train this neural network. So instead we're just going to just make those two modifications. And I'll click back to the standard networks tab so we can see again that we have selected GoogleNet, and there are some links here to the original papers. These are worth reading, and reading over the you can of course just copy and paste the proto-text into a text editor for future reference. It will help you to understand what's going on in the networks. Okay, so further down on this page we have two options, or two ways of selecting what GPUs we want to assign to the computation. We can either just specify a flat number from 1 to 4. In this case, we have 4 GPUs available, without regard to which GPUs get selected for the compute task. Here we're going to use all 4, so I can just say 4, and it's going to select all of them. In some later benchmarking that I'll be doing, I will actually consider selecting a Tesla K80 from 2 different cards. So in some, at least in benchmarking cases, this is a useful feature for benchmarking. Okay, so down here I'm just going to name the classifier. So SUV classifier has an expanded set, and here I just am essentially encoding the parameters that I've chosen, and I think we're running on node 6, so I'm just going to change. Oh shoot. Okay, so that's going to take a little second to re-render there. That'll be back in just a second. Okay, here we are. Alright, so I'm just going to change this to node 6. And we're using 4 K80s, and there's no need to specify which K80s those are because we're using all of them. And then this is a tutorial. And then we just click create, and this will in fact take slightly less than 10 hours to fully compute the network using all 4 K80s. So please later refer to the written portion of the blog where we'll have benchmarking figures prepared so we can compare the runtimes on 4 K80 GPUs versus, say, 2 K80 GPUs on the same card versus 2 K80 GPUs on different cards. And then we will also contrast the runtime to 2 K40 GPUs. Okay, so I'm going to pause the video here. We can see that the cafe training has already started, and down here there's a progress graph that shows the accuracy as a function of time. We'll get to see that a bit later, towards perhaps at some point during the training. Okay, so I'm gonna pause it here. Okay, so just briefly here, I wanted to indicate a feature of Digits 2.1, which is that you can monitor the utilization and the memory usage, and also the temperature of each of the GPUs that are doing the compute task. And here we can sort of monitor the progress of the neural network, its performance as progresses from epoch to epoch. Here we haven't even quite reached the first epoch, and keep in mind that we're going to be training this network for 60 epochs. It's likely that this will plateau in its performance maybe around the 30th epoch. You can actually, if you're satisfied with the performance, you can actually stop the training at that point, and it saves it as it goes along. I have it set so that it saves it at every 1 epoch, and you can sort of monitor the progress here in this window. This is where we launched the server that's running on node 6. We see that it's just a little bit over 1% complete with the task. In this window, I had just a few moments ago launched another Digits server that's running, I I think on, it looks like node 4. So here we see that it's been allocated to node 4, and we can node 4 incidentally has the K40s, so I'm going to do some benchmarking on node 4. So we'll get to see the results of the benchmarking comparing the various configurations of K80s versus the K40s. Alright, we're going to pause here again. Okay, here we are in node 4. Unlike node 6, node 4 has K40s, and we see here there are 2 out of 2 GPUs available. These are K40 GPUs. So I'm just going to do the same as what we did before. I'm going to go to Images, Classification Model, selecting our recent data set, and I'm going to use the same solver options 60 epochs. Select the standard network Google-a-net, and then finally the learning rate. I'm going to modify that to half the default value, just like I had done with the 4 K80s. Okay, then of course here we're going to select both K40s, so there are only K40s on this node, and we're using both of them, and then we just have to name the model, and we're going to say these are where we have 2 K40s here running with the same modified parameters, so this is set to go. Alright, so it'll be interesting to see how long this takes to complete the network training. I will publish the results in a table on the blog, so this will perhaps clear up some questions in the community regarding the performance of K40s and multiple K40s and multiple K80s. So perhaps tomorrow morning I'll resume, and we'll take a look at the result of the K80 calculation, and then we'll get to test the network. Okay, see you soon. Okay, we're back. It took a little less time than I thought it would for the calculation to finish for the model. It took about 6 hours. So once the training and validation is finished, the model is saved to file. Then to test the model, we can upload images further down the page, and we can send these images to the online digits server, or you can provide a URL in this text field here, and this will cause the digit server to pull it off the web. Okay, so here we're just going to upload an image of a Jeep Cherokee, and this checkbox here will tell digits to report the activations for the various layers for the convolution and pooling layers in the neural network. So I'm going to check that box, so when the report comes up we'll also see the activations. Okay, and of course the images that you use to test the model must not be members of the the training or your validation set. Okay, it should just take a few more seconds. Okay, so here we are. So the network classifies this correctly as a Jeep Cherokee. So some of the classifications turned out to be failures, while there were 19 of 21 successful classifications were reported with over 90% certainty, while 7 of 8 failures were also reported with over 90% certainty. So in summary, 72% of the images were correctly classified. So these results indicate that the network is acquiring some information and is able to discern some features between the Jeep Cherokee and the Land Rover. But there still seems to be some problem with this particular network, because 7 of the 8 misclassifications were reported with over 90% confidence level. This might be due to some noisiness in the image set, or there might be some overfitting to the data, despite the expansion of each image set for each respective category to having over approximately 30,000 images. So this concludes this introduction to NVIDIA digits. I hope you have enjoyed this presentation and that you will stay tuned to Microwave's blogs for more information on digits and other new emerging applications. Thank you for listening.